Hello! Over the next few minutes, we're going to provide a detailed explanation for how the algorithm behind Bitcoin mining works. We'll show you where to find the information that goes into the hashing algorithm, and to walk you through a spreadsheet we created that theoretically could mine Bitcoins, though practically is far too slow. The spreadsheet can be downloaded by clicking on the link in the video description. So the main goal of Bitcoin mining is to take a 160-character input message, run it through an algorithm or series of mathematical operations, and get a 64-character output that meets a certain criteria. And what you're doing in the mining process is trying to guess a component of that 160-character input message so that the output starts with a certain number of leading zeros. Once that's been accomplished, that block is mined, and the Bitcoin miner receives a reward, which is currently 25 Bitcoins. Bitcoin mining uses 2 rounds of secure hash algorithm 256, also known as SHA-256, to convert the original message into the output. The one catch is that the original Bitcoin message is too long, so it actually takes 2 rounds of SHA-256 to convert the original message, and then 1 additional round of SHA-256 on the output of the first 2 rounds for a total of 3 rounds. And as we'll discuss in more detail, each round of SHA-256 has 64 steps. And here are the components of the input message. You have the version, which is the block version number, the previous block, which is the hash of the previous block, the Merkle root, which is the hash of all of the transactions in the block that you're mining, the time, which is an approximate timestamp for when the block is mined, bits, which represent the targeted difficulty of the block being mined, and the nonce, which is the random guess that you use to try to produce an output that meets the criteria. Alright, so once you have all that, let's get started on preparing the message. So first, the components of the message are converted into hexadecimal, and then they're rearranged into something called little endian format, which you can see here with the bits. You got 1 little, 2 little, 3 little endians. And you can see how that is applied to the entire input message. These are then combined to give you the full message. Then you get a 1 converted into hexadecimal that is added to the end of the message. And finally, a bunch of zeros are added to pad the length of the message into a size that is the smallest multiple of 512. Taking into account the final portion of the message, which is the size of the message in hex, which is added to the end. Now, to get this message ready for the main hash algorithm, you have to process it as follows. The first 16 blocks of 8 hex characters are what they are. The remaining 48 blocks, numbers 17 through 64, are each produced by adding the block from 16 blocks prior, the block from 7 blocks prior, and then adding jumbled bits from the block from 15 blocks prior and jumbled bits from the block 2 blocks prior. You can actually see the jumbling functions within the body of the spreadsheet. So now your 64 block message has been successfully processed for the main hash algorithm. The main hash starts with initial values of 8 blocks of 8 hex characters, which are provided by the NSA. We'll refer to these as A through H. And the simple part of the hash algorithm is as follows. New B is old A, new C is old B, new D is old C, new F is old E, new G is old F, and new H is old G. You'll notice that we did not mention what new A and what new E are, and we also did not add any of the message to this. And here's how that's addressed. So new A is equal to the sum of the message, which we denote as W, another constant from the NSA, denoted as K, old H, the majority figure, which is based on old A, B, and C, the choose figure, which is based on old E, F, and G, jumbled bits of the old A, and jumbled bits of the old E. Now for new E, that's equal to the sum of W from above, K from above, old D, old H, the choose figure, and jumbled bits of old E. We now have a new value for A through H. This process is then repeated another 63 times to produce a final value for A through H. And then finally, the output from this round is produced by adding the final values of A through H to the original values of A through H. But like we said, the Bitcoin message is too long, so we need to do another round of SHA-256 on the second half of the message. The only difference is that instead of starting with A through H from the NSA, we start with the output from the previous round. We then do the 64 rounds like we just described, and add the final value of A through H from this round to the initial A through H to get the output for this round. This new output becomes the message for the second SHA-256 round. It is padded in a similar manner to what was done previously, and it is also run through SHA-256. If the output meets the criteria, hooray! That block has been successfully mined. If not, the nonce is changed and this whole process is repeated. So here's the actual spreadsheet that we created. The blue cells up here, these are your main inputs. This is where you enter in the block information, with the nonce cell being where you enter your random guess to produce the block hash in yellow that starts with enough leading zeros. You can see what happens when we change that nonce, how the block hash is now changed without the leading zeros in there. Over to the right of the blue cells, you can see how we combine this information into the message. Below the blue cells, we show the output from each of the 3 rounds of SHA-256. The black cells identify calculations, and green cells identify links between sheets. Here on the Message tab, you can see how we process the raw message from the main tab to prepare it to be run through SHA-256. You can see how the original message is split into the first 2 rounds, and then starting in row 132, the output from the first 2 rounds becomes the message for the 3rd round. And then finally on the Hash tab, this is where we actually perform the main hashing algorithm that we described earlier in the video. And there you have it, how to mine Bitcoins with an Excel spreadsheet. Now get out there and make it rain some Bitcoins. You know, with the spreadsheet. Thanks for watching.